Like, no, wait. I'll talk a bit too. We're live. Welcome to Func Prog Sweden, everyone. My producer told me we're live, so we are live. Welcome, everyone. We're so happy to be here. Thanks. Yes. And welcome to Func Prog Sweden at Kivra. Really nice office and really nice to be here. Kickstart with the agenda today then. I will do a short introduction. Then we go over to Swift result builders for fun and profit. So people, you can actually make money of functional programming, and we will hear it from a guy doing Swift. Yes, then hammers and immutability by Emil Hernvall. Yes, we'll see what that is. I have no clue. He hasn't even told me what his presentation is all about. So it could be anything. Power tools, we'll see. Then in the end, short summary by me. But first, I would like to thank Kivra for allowing us to come here to your very splendid office. Thank you very much. Super nice venue, super nice place, and also great food and everything. And if you have questions, wonder anything about Kivra, check for the people in the green hoodies. I have a black one, they are green. Check for the people in the green hoodies. Yes. Also like to thank the video sponsor, Otherbeat. If you want to know more about Otherbeat, check them out in social media or on their webpage. Then schedule for the coming meetups. 21st of March, we're doing an online meetup, and again, 18th of April. Then in May, we'll try to organize one of these live meetups in Stockholm again. So if you have anything to present, or you know any presenter in Stockholm that should present, tell them to come to me. We'll put them on stage. As always, if you want to support the community, join the MeetUp community at Func Prog Sweden. Check out the YouTube channel and make sure to subscribe and follow us. And we've also started up like the Func Prog Sweden Discord server. If you have any more questions, because the YouTube chat is somewhat regulated and hard to like always ask long questions. So check out the Discord server also. And if you really like functional programming and you want to show it, you get one of these cool t-shirts that you can get on the Func Prog Sweden myspreadshop.net. If you have any questions during the presentation, if you're in the room, we'll have a mic we'll send around so you can ask the questions, because otherwise the people online won't hear it. And if you're online, you can use the chat, YouTube chat, or the Discord server, and I will ask the presenters the questions. With that, let's get started. First presenter, Reda. Welcome up on stage, Reda. Welcome.
Thank you, Magnus.
Oh, you're welcome. Now comes the trickiest part of this presentation.
Yep, putting this cable in here.
Yeah. And we'll hope it works.
It will work. Let's not jinx it. Great, it's working.
Woohoo!
Awesome. Good evening, everyone. Again, before I start, I would like to thank Magnus and Kivra for hosting us tonight. This is my second talk in Func Prog Sweden. Last one, I think, was April last year. And somehow it's actually kind of the same topic, but just using a new feature of Swift that I would like to talk about. So yeah, Swift result builders for fun and profit. I want to mention that tonight I'm going to focus on the fun part. For the profit part, maybe I'll have another talk, maybe part 3 of this talk. We'll focus on the profit. We don't want too much competition. The economy is a little bit tight. Let's go. So a little bit about me. Been doing Swift since 2014. That's the year where it was released by Apple. I'm a member of the Swift.org website work group since last year, where we work with the community to create content for the website, but also like to drive the technical aspects of the website. Yeah, as I mentioned, second time presenting, and that's my social links and on my website. That should be enough. My previous talk at Func Prog Sweden was about functional composition in Swift. And in that one, we sort of did a bird's eye view of the language, the functional features. So Swift is not a purely functional language, but it does allow you to do a lot of that, like many other modern languages like Rust or others, or JavaScript. And then we looked into how we can basically compose functions to create APIs. And I think I took the example from the slides. We built a REST client using functional composition. So this was, I think, the last sort of code sample from it. And it was basically creating a request by piping 3 functions, one that does add a JSON body and the path and et cetera, et cetera. This was actually the last thing we had from that talk. If you're not familiar with Swift, I will link to, at the end of this presentation, both these slides, but also the ones from the last presentation. And there's a nice overview of how functions in Swift work and how they're treated by the type system. To move on, today we're gonna, oh, sorry, this wasn't, today I'm gonna talk a little bit about building a DSL in Swift. And result builders is a way to build DSLs. And I'm going to try to mix it up a little bit by using some of the things that we did in the previous talk, but also like doing them a little bit better. And I'll introduce some new examples and new use cases for this. Hopefully it's going to be fun. A lot of the stuff you see here is actually, this is a live playground. So some of this code we will be compiling here. And I'm praying to the compiler gods that everything will work fine. I tried it a few times, but you never know. The first thing I want to talk about is why build a DSL. Like DSLs, so domain-specific language, are a tool to build APIs that are kind of specialized for the domain they're trying to solve. So like the last time we built a DSL for building a REST, it wasn't really a DSL, but close enough for building a REST client. Today we're going to be building that as well. And in my thinking, and I think a lot of people share this point of view, functional programming languages lend themselves really well to DSLs because first, like you can use these functional pipelines that are immutable and predictable to build like these DSLs, this domain-specific language. And you can compose at different API layers. For instance, you can use function composition or other forms of composition that the language provides. So I feel like it's a good match. And Swift in particular wasn't really used like this until result builders were introduced. And I'll talk a little bit about what result builders are and how we're going to use them. Because actually, that's the topic of the entire talk. So they were initially called function builders because they are basically driven by functions. And the name was changed after a discussion, the public discussion in the forums, where some members of the community suggested that it might be misleading because at the end we're not building functions, but we're building types that are created by these functions. It's a nuance, but now like that's something I thought it's worth mentioning. It was introduced in Swift 5.4, so spring 21. So it was out when I gave the last talk, but it wasn't. I didn't explore it enough at the time. So it's not entirely new, but it's still considered new. Yeah, I put a link there to the proposal, which was reviewed within the community and merged. It took a while actually to get it to ship it. So as I said, it's designed primarily for building DSLs, but you can use it for other things and can be used in a lot of scenarios. Let's get actually into some code. The declaration syntax. Before I continue, is that code clear enough for everyone? Like text size, colors? Good. I can actually bump it one more step. All right, so how do you implement a result builder in Swift? It's pretty straightforward. Even if you have never done Swift before, the important keyword is result builder. And this is a macro that's built into the language. And your own type, you can call it whatever you want. Usually it's a struct. I don't think I've ever used this with classes, but you can. but I don't see why you would. Struct is enough here. And in fact, actually, I'm not sure actually you can even use a class here. I've never tried, so I think that's how I've done it before. And then there's only one requirement, which is a function called build block. And this might be a little bit hard to read because these lines are sort of cramped, but it takes a variadic parameter of some type. Let's say in this case, I picked a string here, and it returned just a string. So basically, this is not doing really something. This example in particular is not doing anything interesting, but we'll see some more use cases where it gets more interesting. For instance, in this case, I'm just joining all the strings with a space between them. That's pretty much what this function does. So when I do this, now I have a result builder called string builder. How do we use it? So you can apply it to a function, method, getter, closure, basically anywhere in the language where you would have something that takes something, returns something, you can probably apply this new result builder on. Let's take a look at an example. And this will look weird initially. Result builders, when you see them the first time, is like, this is not what language looks like, because they're kind of their own small universe within the language. But in this example, hello world, it's a function that's marked as a string builder, the one we just created, and it returns a string. It doesn't take anything because all of the arguments are sort of in the implementation. What's really happening here is that here within this function, basically we're already in the realm of result builders. And this function, what it does is, we're going to just find out. So if I run this, yeah, it just prints hello world. It concatenates the two words. And I could add more stuff, and it will just keep concatenating things, basically. You can see it in the output there. If you look at this example, like, it's not very compelling. Like, why would I do all of this just to have a string concatenation? You could do that with a simple function. That's fair. We can do more interesting things. Let's say we can parameterize the function, the one that we're using. And in this case, we'll just pass a name. And if I run this, you will see hello Func Prog Sweden. So far, so good. Nothing really weird. As long as I give it a list of strings, it will concatenate them and spits them back, and that's it. But wouldn't it be more interesting to do more things? Let's say I want to I want to include a number in this output. I want, let's say, create a function that takes an integer and a string and returns a string for the countable. This is where if I try this without doing anything, in fact, we could try it here, it will not work because I do not have anything in my string builder that takes integers. It only knows how to deal with strings and output more strings. The way to add support for additional types to your result builder is basically to extend it by using a build expression method that you have to implement. And in this case, I want a build expression that takes an integer and returns a string. I think I have I'm not sure why this is commented out, but I think I'll just continue with this, and I can comment it in again if I need it. Without getting into the details of basically how build expression works, is that it will wrap every line of the result builder into this new function. So if I add it, let's say, if I add only the first one, the build expression that takes an integer and returns a string, and I try to compile this count label, I will get a compiler error actually, because it doesn't know, so it knows how to deal with integers now, but it doesn't know how to deal with strings. The reason is, when I add build expression, the initial method that we implemented is no longer taken into consideration. Build block doesn't work anymore in that case, because build block knows how to deal with many strings. It doesn't know how to deal with one string. It worked before because we only had a list of strings like hello world was a list of strings. These are all strings and I know how to deal with them. But now that I add build expression, it doesn't know how to deal with them anymore. What I need to do is add another build expression that actually can deal with one string. And the obvious thing to do is to just return the same string. So in this case, build expression string, return the same string. Like, we have nothing to do with string. So now with these two methods implemented, let me run this again. I think I should. With these two functions implemented, we should be good to go. We should be. Do I have an extra parenthesis? Yeah. Yep. Where did I remove it, actually? I think when I, yes, I removed it when I did this. Live coding, you know, it will never go exactly the way you expect it to. But with these two build expressions, now my result builder can deal with integers and can deal with strings, both. And now I can implement a count label. So one question that I see a lot come up in this context is like, how does the count label? So the count label is already a function. I could remove the string builder, and it would still, it won't compile, of course, because there's no return and there's like a few things. But even if, let's say I actually return, that countable, like that string, this will compile, but it won't, like this expression count here is not going to be used anymore. So by adding this, basically we're telling the function what exactly it needs to do with the expressions that are declared inside of it. And one thing here that's important is that the return type of this count label function needs to match the return type of the build expression that we just implemented. So in this case, we're returning strings. At least for this example, it needs to match, because otherwise, if I put here another integer, this won't compile, because it won't be able to know exactly how to take a string and an int and return an int. So we'll go back to string. Now we have this count label function. I pass it an int and a string, and it concatenates them. That sounds nice, but this is actually kind of wrong because we don't say one cars. So let's make it a little bit better. We can add one countable string and one countable plural. The thing that I wanted to do initially when I just picked this up is this. I just came here and said, well, if count is 1, then give me the countable singular, and if it's not, give me the plural. The sad thing, or it's by design, it's not sad, but it's, let's say, unexpected, is that you can't just add any sort of language features in the result builder. It's inside of that thing, you have to abide by its rules. If the result builder doesn't know what to do with it. So what we need to do here, like to actually support, basically what we're doing here is we're defining a domain. So by defining a domain, we need to define everything, including how to do for loops, how to do if. But we're building a kind of not a programming language, but a very specific like domain language. So to support something like if or else, we basically need to, and this is what I said, basically it restricts keywords not explicitly supported. So you have to decide what keywords you want to support in your result builder or not. For if else, we need to support add support for this build either method. And this one, you have to actually implement two methods, one for the first branch. And this one works for conditionals, but also for enums, because enums are just like multiple layer conditionals, basically, or enumerations, depending on which language you use. And so first and second here, and basically I'm not doing anything fancy. I'm just returning the component. It doesn't need to be fancy, actually. This is good enough. Now, if I implement this, I can actually do if count equal 1, then return the singular. If it's not, return the plural. Whereas before, this was crashing the compiler because it didn't know how to deal with if conditionals or conditional. Let's run this now. So now we're using the advanced count label. For 3, it shows 3 cars, and for 1, we expect it to show 1 car, and that's exactly what happens here. Okay, so we looked at build block, build expression, build either. These are some of the most used ones, but there's a few others. And I'm not going to get into all of them because it's sort of, there's a few of them and they have different use cases. But just to give an idea, there's one called build optional, which build optional actually is the same as build either, but only for if you just want to support if, you don't want to support else, just one, then you use if optional. But if you want to support if, else, or enums, you have to do the other one. We will actually see some examples of build final results and build array later on. All right, let's go back now to our string builder. Now our string builder knows how to take a string or an int and return another string. What if actually I want to do something more interesting on the outputs? I wanted to know how to deal with ints and strings in input, but also know how to output a string or an int. Actually, there's a way to do that as well. And that's the build final results. And this one, you can just overload this function with any type you want to your result builder to support on the output side. So if you can see here, I have literally the same function copied twice. The only difference is this one returns an integer, and the other one returns a string. This is basically saying that, well, if you're expecting the result builder to return an integer, I'm just going to return to you the character count of the string. This is just an example implementation. Also very, let's say, very, like it's made up. Like this is not an actual use case. But we return the count. And now, if I mark a function that takes a string and return an int with string builder, the compiler is smart enough to figure out which one of these two to pick up. It's not that hard, actually, because it will look at, okay, string int, do I have any implementation that matches string int? Oh, I see one. Then it will pick this one. I wonder actually what would happen if we had more than one. I think it will always pick the first. We can actually try. Actually, I don't think it will let me because of the type signature, but let's see if I can cheat my way here. This shouldn't let me still because these, sorry. This is I just out of curiosity wanna try this out. So if we run this now, yeah, it actually considers it a redeclaration. So no, you can't overload more than once per type pair, but it was worth trying. All right, so now this function knows how to return the length of a string. So if I do count Func Prog Sweden, it will return 22. The interesting thing here is that this function also calls hello, which, if you remember, we defined it earlier. And hello was another function that took any name and printed hello plus the name. And this is where you can start seeing where this is getting interesting, because now I can put result builders and other result builders. And you know, when that happens, then you have a lot more composability that you can work with. So for instance, in this case, not only I'm returning the count of the characters of, I'm a bit lost, wait. Yes, I'm not only just returning the count of these, but I'm returning the count of these plus the hello that was added by this line. And actually, if you do the math, you will realize that these are 22, but Func Prog Sweden is not 22. I think it's 22 minus 5 or no, 6 if you count the space. So yes, so to summarize this part, result builders, you can have multiple inputs, multiple outputs, and you can decide which which type pairs you want to support in your result builder. And this allows you to have an API or a DSL that's a lot more controlled and a lot more, also you can make it a lot more flexible by supporting more and more types. We good so far? Am I talking too fast, too slow? All right. Next. Now, okay, this was kind of like introducing how it works under the hood. It's not the interesting part. How it works and how it's implemented is what you need to know to implement your own. But it gets more interesting when you look at actual use cases. And from here, I want to take a couple of use cases that I really like working with whenever I'm messing around with not just DSLs, but anything related to API design. And that's a REST client. And the next one I'm going to be looking at is drawing graphics, basic drawing graphics, like nothing really fancy, 2D graphics, of course. So the entire idea of having result builders, for me, what I found interesting in them is the composability. And my last talk was about composing functions. You can still do that with result builders, but then you have this other layer that you can add. So you can compose functions, you can compose result builders, you can have result builders that like work with functions, and you can do like a lot of interesting things when it comes to designing that API. Let's go back to the REST client. So to get started, we'll define this type. Very simplified request method. I removed so many other things, but it has an HTTP method, some headers, and a path for that API. And I'll just have this factory method that just returns a generic get method on the roots. Nothing fancy here, no headers. And this is from the last talk. We made this request transform. And by the way, the last talk is on YouTube, so you can check it out if you want some more context. But request transform is basically a function, and type alias in Swift is just to give a name to a function type, basically nothing fancy. It's a function that takes a request and returns another request. I think the difference from last talk is that I made it to throw errors, because in real life you have to throw errors. So I took this from other projects that I worked on since then, and I introduced the throws keyword here to throw errors. And then, so with this set, now let's get into the interesting part. We want to build a results builder called request. Let's call it request builder, that can build you HTTP requests. That's the goal. We will start by build block. Build block is like the initial example, takes a list of request transforms, and this is where it gets interesting. I'm not passing it around values, I'm passing it around functions. So it takes an array, a variadic number of functions, and returns a new function. This is just, like a run-of-the-mill function composition, nothing really fancy here. And what I'm doing here, I'm just going over those functions and reducing them into some results by just calling them recursively. So there's nothing really here interesting. This should be good enough actually to get started, because I think this has everything. Yep. Okay, so let's define some example transforms. So the typical one is you want to add headers. So I have this function that takes a key value, and it returns another function, which in Swift you can just return the function as like curly braces and close them. That's considered a closure, and in this context, it will be the return type of request transform. I create a copy of the request, set the headers, return the copy, typical stuff. Of course, these are not mutating, so I have to take a copy. I'm not going to pass a request and mutate it. You can do that, of course. And in fact, when you work with the native Apple hardware, a lot of people use the class equivalent of requests, not their own type. I do not like to work that way. That's why I'm talking in this meetup. I prefer to create immutable types and just copy them and make the changes and go on. And so I'll add another one for request method. Takes a string. Usually I don't use strings, but just for the sake of simplicity for the example, I think I'll just go with a string. A request path. That's it. They all do the same thing. And in fact, there are better ways to do this. I could have used lenses or so many tools, but to keep it as vanilla as possible, I prefer just to do it manually, basically, not using any specific tools. And lenses are not built in Swift, so I have to find a good lens library or something like that. Optics, anything like that should be able to do these jobs a lot better than having to type this over and over. Now let's define a couple of endpoints. Now we're going to use our request builder. Let's say we have a user's endpoint, and the path is /users and request method is get. This should be enough for us to actually get an object that has these properties. And I'll define another one called pets endpoint. And here I'm actually calling these. This syntax might look a bit weird, but it's basically just creating the request transform and then passing it an initial request by calling the .factory. So if I remove these, obviously, we're just working with, this is just a function. So I just want to show how you can pass it that argument. So if I run this up to this point, yes, we got our two requests here. And you can see that everything is exactly what we wanted it to be. Method, get, no headers, and the actual paths. Now let's make it a bit more interesting. Let's say we have an auth token that we have to include in all requests. I'll just create a new function that takes an auth token. And under the hood, it calls request header, which is one of the transformers we just defined, and pass it a key, value, bearer token, typical stuff. And now I can use that in my function, my definitions, right? So here, it looks, wait, I'm just gonna make this a bit easier to read so now I added this auth token, but now this function takes a token. Before it didn't, and I just can call this. Same for pets, call this. And now if we look at how this is looking up to this point, you can see that both now have authorization bearer, again, nothing unexpected. But where it gets interesting is, okay, now I'm just doing these transforms over and over. Wouldn't it be better if I actually extract them into their own result builders or result builder instances? And also, let's say, for instance, we have this endpoint /user/ID to get a specific user. I'm not going to repeat that code over and over. So we can do something like this, where obviously I can do it like this, right? But then I'm typing this twice, and if we change that endpoint in the team, I'll have to go around and change it everywhere. So I could do something like I can actually show you how this looks like. So yeah, this works, but we want to make something a bit more interesting. We want to for these like paths here. I honestly don't feel comfortable writing stuff like this, because you miss a slash and it's not valid anymore. It's just a string. Some of your coworkers might forget to rename all of them. It's very fickle. So sure. No, I'm not going to allow it. I don't know what that is. Someone's trying to hack my computer. Yeah, so what I want is actually create something like a path builder. So I will use the result builder again to create these URL paths, because I honestly don't want to write. I don't want to write like anything that is error prone. So just take it to the maximum. A path builder is just a result builder that takes a bunch of strings and joins them with a slash. That's pretty much what it is. Like nothing really fancy. And now I have a better request path that takes. And this is an example I don't think I've shown before. But you can also pass result builders to as parameters. So I mark the parameter as a path builder, not the actual function, but just the parameter. This one is the better request path is just a standard function. It's not a marked function with anything, but the builder it takes is actually a path builder. And the rest is just exactly like the previous one. I create a copy, I call the builder to get the actual string, and I set it to path. So let's say we have the user's root path here, and I also created this helper just to not type get like as a string every time. So this one just returns another request transforms, which is basically the request method with get. And so now if I want to list all users, I could do this. And this is actually where it gets really interesting. Like personally, I feel like it's a lot nicer to read this when I see better request path and I know it's the user's root path. I don't have to worry about putting strings or anything like that. And the rest is just syntax sugar like this get or auth or whatever. Let me run and see if this code actually still compiles. It still does. And yeah, we still get the users here. And for instance, if we're going to go back to the example previously of getting a specific user, so /user/ID, what I should do here is uncomment this ID here and pass it also as a parameter. So now this user endpoint takes a token and a user ID. But I don't think this will compile. And that's because we can't convert. Okay, let's see what compiler says. We can't convert value of int to expect an argument type string. Our path builder doesn't know how to deal with ints, so I just need to implement build expression for that. But why stop at int? We don't have to stop at int. There's so many things that you want to use to build that URL. So I could just use a generic type like custom string convertible. So anything that can convert a string should be good to go to use in a path expression. And in the Swift, pretty much everything almost can convert to string because of the dot description. So it uses mirroring, and it will just basically print all the parameters. Oh, sorry, all the members and their values. So basically everyone, but you don't want that in a path. So you have to, I think this API is not exactly how it's a bit too open, but I just for the case of the example. So now I can do this. I could pass the ID as an int. And I have an example here where I pass the token and ID, and this should give me what I want. So that's user/0. I guess 0 is not a very good. Let's be a little bit more random, you know. 182 sounds random, more random. Yeah, this works. And then of course we can do more interesting things for this path builder. We can define resources. So let's say a user has posts, comments, followers. We can just make it so that it's custom string convertible. This is a custom type, so we're gonna make any custom type string convertible, and then we can use those. For instance, if I want to get like I want to get a specific comment from a user, then it would be the user root path, then the ID of the user, then the resource comments, resource and then the comment ID. And if we try here with an example, we should get /0 / user /0 / comments and / the UUID of the comment. And UUID is also custom string convertible, so I don't have to do anything there. Okay, good. I could improve some things here. For instance, we could do validation. So because the result builder is nothing more than a bunch of functions, you can put any logic there. So if I want, for instance, to make sure that people don't write custom characters in their URLs, I just have to implement the final build. And so as a reminder, build final result is the last method that gets called in our result builder. So whatever other things get called, this is the last one. And you can have multiple of them, of course, as I said earlier, for multiple types of output. But here you can do things like validation, for instance. And in this example, this is actually interesting because I'm using a result builder to build regex. So I think a lot of us here really don't like working with the regex syntax because it's not intuitive, hard to read. I actually put here the original regex. It's hard to see because it's a comment. And also, this is a super naive URL validator, so please don't judge me on that. This is just an example. I'm missing so many things that should be there. But Swift now supports regex using result builders. And you can see a DSL here where the regex is basically, if you read this, is one or more character class, any of these, or this, or this, or this. So this makes it a lot easier to read. And actually, this one is typed. So you can see the generic type. It's super small, but it knows it at compile time, what regex is. And it can actually tell you that this regex is wrong and doesn't make sense. And also, it's aware of what are the rules of regex, not just the syntax of it. Cool. So I have a valid URL regex. I'm just going to check. And if it's not valid, I'm just going to throw a fatal error and invalid URL path component in blah, blah, blah. Otherwise, I will add that initial slash, because remember, we use the slash only to separate members. But sometimes it's good to have that first one. So I added here as well. And this method is great to actually do the finishing touches on your result builder, where validate things, add things, whatever you need to do. Now, I can try this. And I have this one called invalid endpoint. Actually, it's valid at this point because it compiles, but I'll add back the emoji and it won't like it. It will complain. In fact, it will just crash the program because it's a fatal error. Yeah, invalid URL path component in user slash. And this is the kind of really useful stuff to have, especially in a team setting where people don't need to actually know all the rules. They can just use these things, and these things will actually help them kind of ship better software. There are some gotchas, which I'm going to get to later. But for the time being, let's focus on the good part of this. Now to the second example, and this one is something I always like to play with. So whenever I have situations like this where I try to come up with example, I look into drawing, mostly 2D drawing. I'm not into really 3D that much, like flat surfaces. So we're going to build a shape builder. And this, I took a lot of inspiration from existing things, of course, but this is just to showcase how you can do these things on your own. Some imports here that I'm not going to talk about. To define, so what we need to do first thing is, if we're going to build a result builder with something that's abstract, it's good to define a protocol interface. And we call them in Swift protocols. Other languages might have different names, and also they're not always the same. But basically, in Swift, protocols are abstract types that you can make other types conform to, and you can use that as a sort of a type that covers any type that conforms to it. What we need to draw something is a size, and I'm using here core graphics size. I could have used just plain doubles, but this is actually nicer. And we need a draw method that just returns a path. In fact, this method shouldn't be it should be a pure function. Just doesn't take any input. In fact, the type will decide how that drawing process is, and it should just return a path. Path is actually a type defined on Swift UI, so I also didn't want to come up with my own. And we can actually try to look at it. It won't help me here, but let me try one more time. I actually did. So it's just a struct And it's an equatable struct, basically, and it has a bunch of methods. Nothing really fancy, but it's kind of useful because it does a lot of stuff. And then this part I'm not going to talk about. This is we need these drawables to have an ID, and that's mostly because the framework expects you to have an ID so that it can optimize drawing. So if you're going to draw the same thing multiple times and you change nothing in that thing, it will just draw it once and cache it. But if you change the ID every time, it will basically try to redraw it every time. In this case, I don't mind if it redraws it because it's a demo and I'm just going to show it once, so I don't care. I'm just doing it this way so that I can make the program run. And here it's a lot of text, and I hate reading text. So even though I wrote it, I'm just going to gloss over it. What we need to actually use here is because I don't want to be doing the approach we did before where we concatenate things, etc. What I want here is something more akin to reduce, where I have a bunch of things and I just want a final sort of drawable array or path or whatever. And so there's this really nice thing that actually was added in Swift 5.7, which I think was this year, called build partial block. And this one basically works pretty much like reduce, where you get a accumulated and the next. And you can do whatever you want with that. In this case, I'm just appending. Again, I'm not doing anything fancy, but I wanted to show build partial result. Block. This one is extremely powerful in the context of generics. And I did not have any example with generics because they tend to make things a little bit harder to look at. But the reason why it's powerful is because in Swift, when you want to define a generic function, you have to know all the types beforehand. The type annotations, not the types. But to build a variadic generic, that's something the language doesn't support yet. And there's work being done there, and it should be at some point. But right now, you can't have a limited number of abstract types that you don't know about. And this is why build partial block was introduced. And it doesn't do anything fancy for the time being. It just takes a bunch of drawables and one extra drawable, and it just appends it to the array and returns it. I could have done more interesting things here, like flatten them into one path. And in fact, I tried that, but I preferred to keep things a bit simple for this specific case. If you flatten them into one path, you run into other problems like, okay, where should I start drawing these things? What's the origin, etc. So I just wanted to keep it a little bit more straightforward. So let's start with our first drawable shape. We're going to go with a square. And the ID we talked about, so I'm not going to come back to that, and size. And it has this drawing function. This drawing function is actually not used in the result builders. This is actually using the current syntax of path, which is you get basically a function that takes a path and you can mutate the path. I do not like this personally, but I didn't want to complicate things even further. There's actually this really nice library called Path Builder that does exactly this, but without mutating the path itself. And so you can take a look at that if you're interested. But drawing a square is pretty straightforward. Start from 0, 0, go to the height of the size, and then you get it. I have to do the travel all the 4 points, and then I close the path on the end. Nothing really fancy here. So we annotate. Let's say we have this function that draws two squares and returns any drawable, and we annotate it with shape builder. And now I can just put as many squares as I want here inside, and it should be able to draw them. Here you can see the outputs in text form, the data, but this is not very exciting to look at. This is actually kind of confusing at some point. So what we want is actually being able to draw these. And for that, I'm just going to introduce this thing called a shape canvas, which basically holds all the shapes and then knows how to draw them. How to draw them isn't really the point of this talk, but I can mention it briefly. What it does is, so first the init takes a shape builder so that I don't pass it an array, I pass it a result builder so you can do all of the logic inside. And once we want to render it, I have this render method that uses Swift UI under the hood to render it. Also, it's nothing fancy, it just goes over the shapes and then it draws them, it strokes them, and it sets the frame based on the size. So like it's pretty straightforward. And also do this thing where odd shapes or even shapes have different colors just to be able to see which one is which. I had one with a lot of colors, but I didn't have the time to do it properly, so it became like really hard to look at because it had so many colors and it was random basically. All right, so shape canvas, and this part is just to make it work with the playground. So nothing really. In fact, I can just hide this one, and yeah, time to render this. So we're gonna call this first. Yeah, okay, well, happens. It's coming. Yep, see, told you. So here's the first, actually the first one we didn't look at. The first one draws the two squares. Damn, I just realized I picked the colors that are not very visible. You know what? We're gonna make it yellow. And which color was that? I don't think salmon is predefined. I have to write. I think I'll go with blue. Although they have a dark blue, so it's not very easy to see. But let's see. Could also use hex. Come on. Yes, this is better, at least for seeing it. Yeah, this draws the two shapes that we have. But you can see here that actually I just called shape canvas with the two squares, which knows how to draw a two square, and it does that. But I can also do something like this. Second drawing, I just copy paste a bunch of squares. And this is gonna start getting a bit psychedelic. But this is it, yeah. And it looks promising, but obviously most of you are probably thinking, who wants to be copy pasting stuff like this? Like, this is really not good. So we want a for loop, right? Because that's where you start getting interesting generative things, right? So for loop, just like if and all the other things, is a special syntax. You don't get it for free. So we have to actually add support for it. The initial idea was like, okay, well, I can just go and do shape canvas for I in 020. I want to do this, but this won't compile because it doesn't know how to deal with something. It doesn't know how to deal with an array of something. Yeah, but basically what the compiler is trying to tell us is that I don't know how to deal with for loops inside your result builder. You have to define that logic. So we'll do exactly that. You do that by implementing this function called build array. And it takes a, let me put a new line here so that you can see. It takes an array of an array. So you have to flatten them. I mean, in this case, I'm flattening them, but you might want to do something else. Like, for instance, if you want each group to have their own color or whatever, you can do that. But in this case, I don't care. I just want all drawables to be one flat thing. And that's what I did here. And this one I didn't have it initially. And this is actually, it took me some time to figure out because I thought this should be enough. Build array should be enough. But when I try to compile, it says, I don't know what to do with this because like to do this partial block, you need to have this method. And I think I can go back here that knows how to take one element and do it because typical reducer want to give it a default value. But in this, like not a default, but an initial value. But the API, the way it's designed is that you have to actually have these two methods, and I'm going to show them to you. So yeah, this one is the one that accumulates, but notice that there's this one that takes the first drawable. So the first drawable needs to be a single item, but that's kind of an arbitrary limit. So I don't want that. I want to be able to do whatever I want. So to do that, we basically just need to implement this other method that knows how to deal with an array as the first expression in the block. So you can see here, the first is an array, whereas the one above the first was a single value. With this should be good to go. So now it's just 0 to 20. And yeah, it's starting to be a little bit easier to read, at least. You know that we're just repeating code here. We can also define other types. Can define a lozenge type, which has different drawing instructions, but it's pretty much the same as a square. And I could then like have both of them in one drawing. You know, you get the idea. By the way, this I was looking at, and I ended up, I think, with an illusion because the blue lines don't look straight to me. I'm not sure if I'm the only one, but the blue lines definitely were like, they look weird. And I realized that apparently it's a thing. It was an accident. I didn't actually plan to do it that way. Cool. So the thing about this drawable thing that we defined is that now I defined two shapes, but you can make literally anything drawable. Because it's a protocol, I could make a string drawable. Like, okay, I just took a native string and I'm making it drawable. Now, of course, how we're going to draw a string, I didn't bother myself too much. What I'm going to do is just I render it as dots. So each letter is a dot, like password. Obviously, like you could do something more fancy where you know the actual vector shape of your font and you actually draw that as a shape, you can do that, but not for this demo. I'm not going to do that. We render them as dots. And in fact, as ellipse, this is add ellipse, and yeah, the logic is there. I added this other canvas which stacks things. If you notice, the canvas we worked with so far just puts things on top of each other, but that's not what I want with strings. I want them to be stacked. So I defined just copy paste basically, and I changed a couple of things just so that it stacks. So now I have the secret message, hello, this is a secret, very secret. And if we run this and not get any compiler errors, we should see some dots. This error actually I've seen before, and it's kind of annoying because sometimes just restart. Basically, it's trying to tell me that I can't use result builders in anything below macOS 15. Because the thing about Swift is that if you run it on Linux or Windows, whatever comes with the standard library is what you can use. But on Mac, a lot of things are actually shipped with the OS. So there's this strong coupling. And I think here, if it doesn't work, I can just restart, and typically it works. Actually, there's only these 2 examples left, so it's not a big deal if they actually don't show anything. But here, what's going to happen is that it's going to be basically like 3 password sort of renders. I'll come back to this because I'm pretty much done. So I'll come back to this at the end. Hopefully, it's gonna run. So I mentioned earlier that there are some gotchas to these. Like while these tools are pretty strong. In fact, in this example, you can see that I have copy pasted this. I could have used the for loop, but then I just snuck in a string there, and it actually knows how to deal with it because it knows how to draw a string as well. I wanted to show the sword. It was fun. I'll come back to it. This was like an issue I've dealt with earlier today. So there are a couple of gotchas with not just this, but all DSLs. They have the same kind of gotchas. And the first one is like the learning curve is usually steeper. So like you work with a language day in and day out, and then someone comes and says, well, now you have this block of code that you can't actually use all the things you know in the language unless you implement them yourself. It's a pill that's a little bit hard to swallow, but it has its use cases. Sometimes you don't want people to write any logic. You want them to write exactly this logic. Let's say the case of path I gave earlier, you don't want to give that freedom, like you do whatever you want. No, it's a URL path, and I want it exactly to be like this. Works for things like anything with a tree-based structure, like HTML, or literally anything that you want structure, and you want to enforce that structure. Regex is a good one as well. The other thing, oh yeah, so here I wrote the black box effect. It is kind of a black box because if you use it for the first time, you don't know how it's actually, what it's capable of. The other one is getting better, but autocomplete sometimes doesn't know what to suggest, because like say when you do dot syntax or functional chaining, the compiler knows what other possible things. In a DSL, it doesn't. You can just go to a new line and there's literally nothing it can suggest. It depends on how you made it, but like, yeah, it's not as good as in that aspect. But it's improved, and like there's a lot of work that the core team are doing to make that a little bit better. Here are basically some real world examples. I tried to order them by how popular, like how used they are. Not popular, but like the biggest example is Swift UI. And actually there was an example of Swift UI here up somewhere. The entire feature was actually built so that Swift UI can be built. So it was actually interesting sort of a situation where this needed to ship in the open source project so that the closed source Swift UI can actually be shipped. Yeah, I think I have an example here somewhere, but you get the idea. I don't have to look for that now. Regex Builders is another one that's now built into Swift. You still have to import the library, but it's an official package. There's Swift Composable Architecture, which is a kind of like application architecture based on Redux and unidirectional data flow. This Swift Charts, which was also made, I think, sometime last year, where you can define charts based with that DSL. And it's actually pretty impressive. I think Swift Charts is probably my favorite tool to make charts now. I've used so many things, including like JavaScript, Python, but this is my favorite now. I could have done a fuller demo, but I think this should be good enough. Yeah, basically you can do exactly the same things we talked about. There's also a bunch of community contributed things like this data example where you can build array of bytes using that. GraphQL is an example I've seen multiple libraries try to do. I picked one, but there are few of them, which makes writing GraphQL queries type safe and much nicer to work with. HTML is another example where a lot of people are trying their hands on. I know this one is a bit divisive. Like, a lot of people don't like DSLs to write the HTML. I actually happen to be one of those people. I like writing HTML by hand just because I'm old school. But some people don't like that and don't want to touch HTML at all. So this kind of, but I'm actually starting to soften up a bit on this stance as time goes on. So there's so many more examples. I actually linked to this repository called Awesome Result Builders in Swift, and you'll find so many examples. For some further readings and resources, there's the official programming language book that has I linked specifically to that chapter, and then there's a couple of videos that introduced writing DSLs in Swift, and there's the actual proposal, which is amazing, and I think it's worth reading through, even if you don't write Swift, to have no interest in Swift. Just the thinking process that went into building this feature and shipping it. It took many iterations. I think it's a very good example of how open language design happens. Yeah, I think, thank you. And if you want these, you can try to scan this. There's a URL, but otherwise it's going to be either in the video or in the meetup page. Yeah, so thank you.
Thank you very much, Reda.
Yeah, welcome.
Thank you. Yeah, and please stay for questions. They're not getting away.
I skedaddled, sorry.
Yeah, no worries. No questions in the chat so far, but I would like to say very daring of you to do live coding.
Oh my God, it didn't work for the sword example. I'll try to go make it work later, because that was cool. It was like a sword made of lozenges, and then it's cool.
It would be really nice to see, right? Is there any questions in the audience here? No one dare to ask any questions? No? Okay, fine.
I answered all the questions. It was perfect.
Yeah, it was
no room for...
perfect presentation. Yeah, and you really handled someone try to live hack you also.
Oh, yes, that was scary.
Okay, again, thank you very much, Reda.
Thank you, everyone.
Yeah. Thank you very much. And then welcome up on stage, Emil. Thank you. You're welcome. So let's see if the laptop works. Yeah, maybe we should just let the people... Yeah, let's see if the laptop seems to work. Perfect. Getting the display and everything up. It's always a challenge. Not showing. Is it? Yeah, you don't want to show any secret code and the proprietary stuff in your email. Oops.
Actually, took the precaution of closing Slack.
Smart. I usually do that. Signal. Yes. Close the mail. Good. Oh, we need to swap your audio. Yes, so let's see. We're swapping audio, and everyone in the audience, which you can't see live, is getting more drinks and food. Cool, and I can give you a sneak peek to everyone online not seeing, but I see power tools as we hoped for.
Of course.
Yes. Good. You're good to go, Emil.
All right. Thank you, Magnus.
Yeah, you're welcome. I'll sneak back behind your back here.
Cameras are over there.
Yes.
Okay. I'm Emil. I'm currently a senior software engineer at Amazon Web Services, although I'm here tonight speaking on my own behalf with all of the usual disclaimers that goes with that. Today I'm going to draw on this old metaphor, which most of you have probably heard of. Give a boy a small hammer. Give a small boy a hammer, and he will find everything he encounters needs a pounding. This is apparently the original form of the quote, due to a man called Abraham Kaplan, who said this or wrote this perhaps in 1964. A few years later, another Abraham rephrased it as the more commonly quoted variant. If all you have is a hammer, everything starts to look like a nail. And we can, of course, imagine that we can modernize this further, like give a programmer a screwdriver and he will screw everything up. Or perhaps this relatable formulation. Give a grown man a compiler, and he will find that everything he encounters needs a good pounding. So why am I even talking about this? I firmly believe that certain ideas are good enough that they can be used successfully time and again. These are rare and far between. But I will argue that immutability is one of them. It's our metaphorical hammer that actually turns everything into a nail. I will attempt to do this by telling you 3 stories about different hobby projects that I've done over the years. They are, in my opinion, good examples of why immutability is so powerful in practice. And I find them to be reasonably representative of actual things I've encountered over my professional career. First, let's talk about the IRC server. The background for this project was that I wanted to do something more complex in Haskell. Over the years, I've come back to Haskell multiple times and done things like Advent of Code or Project Euler. But the problem with that sort of toy exercise type problem is that it never really got me to dive into the things that are actually fundamentally different about the pure functional language like Haskell, like side effects and other considerations. So I decided when I came back to this the other year that I needed to dive deeper, and in order to do that, I had to pick a good project. Decades ago, I used to love IRC. In the past, I've written several bots, several clients, at least one server. So I kind of knew the project really well from that past life. And as protocols go, IRC is a pretty nice one. It has a straightforward ASCII representation that is easy to part. The spec is admittedly long, but you can get away with only implementing a small part of it in most situations. So it was kind of just right for this, because ultimately IRC is by its nature a highly stateful protocol with plenty of side effects. From reading about this every now and then, I had heard of this concept of the state monad. So I figured, as I first started looking at this, that sounds like something that I'm going to need for managing the state in this application. And that turned out to be completely wrong. Once I got started, I quickly realized that there is a much easier and arguably much more standard way to approach this. I will walk you through some bits and pieces of how I ended up structuring the server. The first snippet just shows you the main function of the program. It creates a new channel that will use to pass around events, initializes the server state, in this case, just a map of users and a map of channels, and kicks off a new green thread for processing events. The event thread will read events from the bus and update the state, and then we start the main loop. The main loop here is really simple. We wait for a new connection, spawn a thread per client, and then we recurse and do it again. The client handler starts out by creating a new channel that will deal for things that are heading specifically to this client. And then we wait for a user to identify themselves. This yields a user structure that contains things like the nickname of the user, but notably also the right handle of the channel that we just created. Finally, we pass that new user off to the event thread wrapped up in this new user variant. The per user thread will keep running until the client disconnects, reading messages from the event thread and writing them to the socket, and conversely, parsing messages from the client and then passing that over to the event thread. This may be hard to follow from that description, so I drew you a picture. So when there are no connections, there are just two threads. The main thread that waits for new connections, and then the event thread, which waits for something to happen. When a new connection is established, a new thread is spawned for that client. It waits for the user to identify itself, creates a new channel for a user, constructs a user object, and then passes that over to the event thread, which will update the state and specifically insert the user into the map that stores the connected users. It then spawns a writer thread that reads the per user handle. So now when something happens on the event thread that it wants to pass to a specific user, it can send on that handle, and this will take care of actually writing it back over a network to that particular user. So whenever something happens for any client, that all gets passed to the event thread. If state changes, the changes are applied to these maps. And if the user should be notified about something, we can pass it this way as I described. So let's look at the actual event thread. It reads events off the channel, updates our channel map and user map, processes messages if relevant, and then turns it back on itself using tail recursion. I use update somewhat sloppily here because we're not actually updating anything in place. And this is Haskell, and we're dealing with immutable data structures. So what we're really doing is that we're cutting off the branches of the existing trees that are still relevant to us, substituting them onto a new tree, and returning that back. So let's dwell on this for a second, because from an imperative perspective, this is really weird. We're not actually storing the state anywhere. We're just applying the changes and calling ourselves again. It's essentially juggling state rather than storing it, since it's always in motion. This sort of architecture is really widespread in network applications in general, irregardless of programming language. One of my favorite books is Java Concurrency in Practice from 2006, because it does such a good job of introducing the fundamental way to think about concurrent applications, even outside of Java. And they note explicitly that if you don't share state, you won't have much trouble. The approach that they propose is very similar to this one, with channels, or I guess it's Java, so it's I guess, concurrent linked blocking queue or whatever. But essentially channels as a foundational primitive for passing state between parts of the program without ever sharing it. To really emphasize this, here's an event loop in Rust, which is mostly analogous to our Haskell one. This snippet can run in an isolated task, and the state can be kept to the specific function. We don't actually have to put it in a struct and share that around the program, or just straight up declaring it ahead of the loop and keeping it there. And in that way, we can avoid most of the problematic situations that you can get into when doing concurrent programming. So let's talk about JavaScript. I have this game that I've been addicted to for 12 years or more called Bubble Spinner. I tend to play this endlessly whenever I'm in a meeting or taking a pause to think about something. It has happened on occasion that I've been in a meeting actually presenting something, forget that I'm sharing, and starts playing Bubble Spinner in front of the entire meeting. It's a deep-rooted reflexive action for me. This was originally a Flash game on some website that someone sent me back in 2009, maybe. So I kept playing it on that site, dutifully watching the advertisements for years. But then it got to the point that it became kind of a hassle to keep installing Flash, specifically because I wanted to play this game. So I got tired of it and decided to write my own implementation of it. And by the way, the link is down here if anyone wants to actually try it. So when I was playing this game, I always had the sense that the rotation and collisions felt very intuitive. This was one of the main reasons why I worked up enough excitement about it to actually sit down and implement it, because I wanted to check if my intuition for how it worked was correct. And it turned out I was indeed right about it. The result that I eventually produced matched the original game very well. Some friends of mine even said that it felt even better than the original game. For non-physicists, there is this concept called moment of inertia, which essentially measures how difficult it is to make something revolve. It's calculated as the sum of the point masses, in this case are bubbles, that make up the object, and then multiplied by the distance from the axis squared. There is another quantity called angular momentum, which is the rotational analog of regular momentum. Interestingly, it's a conserved quantity, and it's the reason why the planets stick to their plane, and how gyroscopes work, and so forth. We can calculate it as the cross product of the position vector times the linear momentum. And the magnitude of the angular momentum is equivalent to angular velocity times the moment of inertia. So for this game, we want to find the change in angular velocity when you strike the frame of bubbles with the projectile. So what has all of this got to do with immutability? No idea. I just wanted to talk about physics for a bit. So back to programming. The physics weren't actually the most difficult part of this. Rather, by far the most complex piece was figuring out how to render the bubbles around the hexagon and various matters related to that, because it turns out that the universe and the mathematics in our universe really doesn't like this arrangement. So I ended up with quite a bit of a relatively complex state. For instance, for every single bubble, there are 7 separate variables here. 4 of them dealing exclusively with the position of the bubble within this arrangement. I will spare you the nitty-gritty details of this, but this entire game is written in very heavily commented JavaScript in an attempt to actually make it readable. So if you're curious about the details, you can go and just view source on that page. So this is where I have to caution more sensitive programmers who may already be suffering from PTSD due to a history of intense legacy code work. There is no shame in looking away for this part. So this ended up requiring some of the trickiest conditional logic that I've ever written for any reason. Because it, as I mentioned, this doesn't have a very clean mathematical formulation, and I ended up with edge cases galore, or perhaps edge cases gore. This portion is from a method that finds all of the adjacent bubbles. I cut out about 2/3 of this function to make it fit on the slide. The rest of it isn't any prettier, in addition to having a bunch of edge cases like this one down here, where the result is different for some specific value. There's these very error-prone expressions for calculating the adjacent bubbles. You can probably imagine that it took quite a long time to track down all of the bugs in this and get it working reasonably well. Frankly, the adjacency search was probably the trickiest part of this game. But there were plenty of other messy situations, like this thing, which actually performs the search for the bubbles to remove in the event of a collision. That just has a lot of potential for errors. But I submit to you that it isn't a mess, that is the true problem. If you only have a single variable and you perform some tricky computation on it, that's still usually highly manageable because the state space is quite small. Once you find a problem, it's trivial to trace through it in order to figure out where it goes wrong. For a program with lots of state, the state space is just so large that you may never be able to test the full state space, especially if you're also dealing with high cyclomatic complexity, which was the case here. So how then did I ever get this working? The key trick was to make the entire game state immutable. So rather than updating the existing game state, I had the tick method return an updated copy of it. And that was probably the thing that ended up saving this entire project, because then I could just keep a sort of audit trail of all the past states before each user input. And then I wouldn't just sit down, play the game for a while. When something broke, I could open up the developer console, call a function that I had placed in there to just reset it to just before, just after that event had triggered, and then step through it in the debugger. I think ultimately that it ended up taking multiple weeks of on-off playing it before I had rooted out most of those really subtle bugs. But even to this day, my wife will sometimes complain to me when she's playing this and it randomly freezes. And, I don't have a the patience to go track down the final few that remains in there somewhere. So as usual, this is not a novel idea even in the front-end world. The concept of immutable state in web applications and how it could help seems to have really taken off sometime after React became popular, probably due to it pairs really well with React's emphasis on unidirectional data flow. So here's a snippet taken from the Redux state management library documentation. Immutability can bring increased performance to your app and leads to simpler programming and debugging. The final project I want to talk about is one from a long line of projects that made my wife contemplate her life choices. Sometime after we had our first child, the number of family photos had predictably grown unmanageable. She asked me if I could come up with some sort of solution so we could easily share photos at home. And naturally, my reaction was to implement a fully custom solution. I wanted an application that could run on my home server that would use the iNotify kernel API to monitor a folder for new images and automatically rescale them in the background. And that would ensure a quick and smooth experience because when you were actually loading a gallery, all of the work had already been done in the background. I explained this plan to my wife, who sighed heavily and asked whether I had looked around for existing solutions for this problem. And obviously the answer was no, I still haven't to this day. This was one of the earliest projects that I ever did in Rust. So I struggled a bit with the borrow checker and the restriction that mutable access is exclusive to a single location in the program. The core problem was this piece that we see here, which represents a folder in the gallery. And remember that I wanted to update this in the background as new changes to the file system were detected. But even when that was ongoing, I didn't want to prevent clients from accessing the web frontend. So the easiest way to deal with this is to wrap the full thing in a lock. This works, but provided a lousy experience whenever we added new images in bulk, since the contention on the write lock ended up being significant. Intuitively, one may be tempted to add a lock within the image gallery struct around one of these nested galleries. Unfortunately, that doesn't really help in Rust due to the use of resource acquisition is initialization guards. In order to even access an inner lock, you need to take all of the outer locks as at least read locks. And if you realize that you want to apply a change, then you have to go back up and take the write lock all the way down. So we can do much better than that if we observe that we are happy with the eventual consistency. All indirections of this structure are through atomic reference counters. So the image gallery structs all live on the heap, and immutable access is possible from all threads throughout the program. When something changes, we can keep the portion of the tree that didn't change, rebuild the part that did change, and then we swap out the full tree. Any concurrent readers of the previous tree will still observe that. And once they are done, they decrement the reference counters, and if needed, the unused portion of the tree gets allocated. This is essentially exactly how the tree maps that we saw earlier in Haskell works. So, content with my neat solution to this problem, I lost interest in the gallery application, and it remains mostly unfinished. My wife remains annoyed. That's all I had today. Thank you.
Well, thank you very much, Emil. So have you found any other ways to share pictures? There are several.
I think Apple kind of snuck up on us.
Okay.
Discovered incrementally.
They solved your problems.
Well, I didn't. I didn't approve this. It just sort of happened.
Your wife approved it.
Yeah, that's true.
Okay.
That's ultimately the main thing.
Okay. Thank you. Well, there's no questions in the chat so far. Anyone here has any questions? No? Maybe you want to build this gallery with Emil? No volunteers. Okay. Then thank you very much again, Emil.
Thank you.
Yep. And thanks everyone for both the viewers online, and thanks everyone for coming here. To the viewers online, goodbye, and to everyone else, please stay around, stick around, grab more beer and food until we're done. Thanks. Then we're done.